Hello everyone, welcoming you to Shore Sir's classes. And today we are looking at the General Economics Paper 1 IES 2022 and question number 13 of the paper and part A of the problem first. Show that the marginal cost cuts the average total cost at its lowest point. Okay, so obviously diagrammatically this can be done, but using 2-3 steps of algebra you can easily do that. So let us suppose that the cost function is C, which is a function of Q. Okay, fine. And we have this standard assumption. What is marginal cost? It is del C del Q. And what is average total cost or average cost? It is C by Q. C as a function of Q divided by Q. So in order to find the minimum average cost, what we'll do, we will differentiate average cost with respect to Q and set it equals to 0. So if you do that, what you will get is Q times C prime Q minus C of Q divided by Q square is equals to 0. Correct? So Q will be positive. So if you take to that side, C prime Q minus C of Q is equals to 0. That means Q times C prime of Q is equals to C of Q. Correct? So if you just interchange sides a little, C prime Q is equals to C of Q divided by Q. Okay. Now if you look at this, what is this? This is essentially the marginal cost. And this part is essentially average cost. So what is the conclusion that you get? Therefore, at minimum average total cost, marginal cost is equals to average cost. You can check the second order conditions as well. You will get to better clarity. But this is what you were required to prove. This was the question that was there. Okay. So now let's move on to the next part of the question, which is part B. So let's have a look at it. The short run cost function of a competitive firm is given by C equals to 0.1 times x cube minus 2x squared plus 15x plus 10, where notations have their usual meaning. Derive the short run supply function of the firm. Okay. So coming to part B of the problem. Part B. So the cost, which is the function of output, which is denoted by x over here, is given by 0.1 x cube minus 2x squared plus 15x plus 10. Correct? So we need to derive the supply function of this firm. So how do you derive the supply function? Supply function basically represents the profit maximizing output level that is produced at each price, right? This is what, for each price level, what is the output that you should produce in order to maximize profit. Now since we are talking of a competitive firm, price is a parameter to this firm, so it's a price taker. So for all possible set of prices, this determines what is the profit maximizing output that needs to be produced. Correct? Therefore, so profit is basically P into X minus C of X. Correct? So what do? You maximize pi with respect to x and set it equals to 0. So P minus dc dx is equals to 0. That means P should be equals to dc dx. Now if you compute dc dx from this equation, you basically get 0.3 x square minus 4x plus 15, right? This is what you get. Fine. Now, before actually going in with the computation, one thing I hope that most of you are aware is that a comparative firm will only operate if price is greater than minimum average variable cost. That is a very crucial thing to observe. That a comparative firm will be operative because that is the shutdown point. Beyond that, its losses cannot be recovered and hence its shutdowns. So before actually going into the calculation, let me just mark it as 1. It will help us to do a calculation of the supply function later. But let us see that what is the minimum price level beyond which the firm will not be operative. Because below that point, the supply function will not exist. So let us see. Given the cost function, let me just write it down once more. It is 0.1 x cube minus 2x square plus 15x plus 10. So this part which depends upon x is the variable cost and this part is the fixed cost, right? So average variable cost, which is a function of x, will be 0.1 x square minus 2x plus 15, right? Correct. So for obtaining the minimum ABC, because we know that the shutdown point is price equals to minimum of the average variable cost. So we need to determine that. So what do? We again differentiate average variable cost with respect to x and set it equals to 0. So 0.2x minus 2 is equals to 0. So x turns out to be 10. That means that output level equals to 10. You have the minimum average variable cost, and what is the price that will be price at which it occurs. So from equation 1, if you take a look at it, P will be equals to 0.3 times 10 square minus 4 times 10 plus 15. So 0.3 into 100 minus 40 plus 15. So that will be 30 plus 15 minus 40, which is 5. Therefore, what we basically obtain is, if price is greater equals to 5, firm operates in the market, otherwise not. This is a very crucial observation. Now note that from equation 1 that you got, it's kind of an inverse supply inverse supply function. Given a quantity, you try to see what the price is. But actually the comparative form works otherwise, right? So let me just write down equation 1 once again. So equation 1 is basically P equals to 0.3 x square minus 4x plus 15, right? So from here we need to obtain x as a function of P. This is the supply function. So what do? We need to solve for x from this equation. So how can we do? Remember that P is a parameter for the comparative form. So it's basically something like a constant at any given instant. So we can write it in this way: 0.3 x square minus 4x plus 15 minus p is equals to 0, which is essentially a quadratic in x. Correct? So how do we solve this quadratic? It's equals to minus b plus minus root over b square minus 4 into a into c divided by 2 times a. Now obviously the minus sign is to be ignored. Therefore what is left is that x equals to 4 plus square root over 16 minus 4 into 0.3, 15 minus p divided by 0.6. So this is basically 4 plus root over 16 minus 1.2 times 15 minus p divided by 0.6. Therefore, what does the supply function look like? Given a price, it will produce output according to this condition, where p has to be greater equals to 5. This is my supply curve for this comparative firm. So now moving on to the next part of the question, which is part C. So we need to show that the elasticity of demand is the same at all points on the demand curve. And the demand curve is x equals to a into p to the power minus alpha. Okay. So part C, x equals to a into p to the power minus alpha, where a and alpha are constants. So in order to find the elasticity of demand, what I can do is simply take log alpha equals to log a minus, sorry, not log alpha, log x equals to log a minus alpha log p. And now take the differentials. D of ln x equals to minus alpha d of log of p. So minus of d ln x divided by d of log p is equals to alpha. And what is the left hand side? It is the absolute value of price elasticity of demand. And since alpha is a constant, the price elasticity of demand is constant for all points on the demand curve, which is a constant. Therefore, mod EP is same at all points on the demand curve. So now moving on to the next part of the question, part D. Consider the demand function of two goods x1 and x2 respectively, given as this: x1 equals to p1 to the power minus 0.7 into p2 to the power 0.2, and x2 equals to p1 to the power 0.6 and p2 to the power minus 0.4, where p1 and p2 are the prices of x1 and x2 respectively. Determine whether the commodities are complementary or competitive. So competitive basically means substitutes. Okay, so let's come to this. Just a moment. 0.6 and minus 0.4. So these are the demand functions. Now, what do you mean by substitutes? Let me explain with the help of example. What do you mean by complements? Both of them are used together. So let's say if the price of the other commodity increases, then if by the law of demand, the demand for the other commodity will fall, correct? And since x1 and x2 is complement, demand for x1 will also fall. That means del x1 del p2 should be negative. And if it were substitutes, what does it mean? If p2 increases, then demand for x2 would have fell. Since they are substitutes, you can use the other good in place of this, and the demand for x1 would increase. That means del x1 del p2 is positive. So we basically need to check these two conditions, which of the one hold for both the goods. So for good one, these two conditions that I have written over here, and for good two, the other way around. Whichever one holds will be validated, right? And note one thing, that x1, x2, p1, p2 are all positive, right? So let's take the x1 equation first. So x1 is equals to p1 to the power minus 0.7, p2 to the power 0.2. So this is a demand function. So I partially differentiate this with respect to p2. So p1 times minus 0.7 stands out, 0.2 p to the power minus 0.8. So that is 0.2 times p1 to the power minus 0.7 p2 to the power minus 0.8, which is greater than 0. That means it's a substitute. And similarly, if you look at the second one, x2 equals to p1 to the power 0.6, p2 to the power minus 0.4. So I'll differentiate x2 with respect to p1, the price of the other good. That is how we can determine whether it's complements or substitutes. So 0.6 p1 to the power minus 0.4 into p2 to the power minus 0.4, which is again greater than 0. So this is also a substitute. So from these two, what is your conclusion? x1 and x2 are substitutes. Okay, that's the answer for the last part of this question, part D. Thank you.